Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's Dark Reading webinar, The Unreasonable Effectiveness of Inside-Out Attack Surface Management. It's sponsored by runZero and broadcast by Informa. I'm Peter Cross with Dark Reading. I'll be your moderator today. And before we get started, I have a few quick announcements. First of all, this webinar is designed to be interactive. There's a dock of widgets at the bottom of your screen, and that will allow you to learn about today's speaker, download resources, share this webinar via social media, and participate in the Q&A session that we'll have toward the end. The slides will advance automatically throughout the event, no need to click, and you can download a copy of the slides via the resources widget. Toward the end of the webinar, I'll ask you to provide some feedback via the survey widget. You'll find that at the bottom of your screen. And I hope you'll complete this survey before you leave us today. Your information there can help us to improve these events in the future. Finally, if you have any technical issues during this webinar, there's a couple of things you can do. One, click the help widget that's at the bottom of your screen, or just type your issue right into the Q&A area. And either way, we'll be glad to offer one-on-one assistance. All right, that's it for the announcements. Let's move on to our presentation. The Unreasonable Effectiveness of Inside-Out Attack Surface Management. To discuss today's topic, we have H.D. Moore. He's the CEO and founder of runZero. If you'd like to learn more about H.D., you'll find his bio on your screen under the speaker bio widget. And again, if you'd like to ask a question to H.D., just use the Q&A area. Just type your question right in there, and that's on the right side of your screen. With that, I'm going to hand it over to H.D. Moore of runZero. H.D., take it away.
Awesome. Thank you, Peter. Rich introduction. First off, thanks for your time, everyone. I'm really excited to share a project we've been working on for a few months here. We've been looking at the attack surface management challenge that some of our customers have presented and trying to find ways to kind of crack that problem that are a little bit different from the standard. And we think we've got some great ways to help you find stuff that's exposed that really doesn't show up any other way. And I'll dig into that right here. So just kind of set the stage a little bit. My background is mostly offensive security. So I started off writing exploits for the DoD, got hired out of high school on an IRC channel to go write exploits. Spent a lot of time working on Metasploit, about 15 years there. And through that whole process of constantly breaking into stuff or writing exploits to break into stuff, the hard problem for all is just identifying what was there in the first place. So first, identify what's there, identify how it all connects, determine what's most important, and then go after the weakest link first. And from a defender standpoint, you actually want to look at it the exact same way, except for the fourth step here. Instead of attacking it, you're mitigating it. But the idea is that until you have a really good lay of the land and know what's out there, you don't really know what's most important. If you don't understand how all the different parts are connected, then what could look like the most important part of the network or the most important choke point for a security control may not actually be the most important one. You could have something like a device that's multi-home connecting your PCI CDE to a non-CDE network and effectively don't see that and then don't treat that asset as a critical asset as a result. Lastly, once you do understand what's most important, you should figure out what is the weakest link in your security controls. Is there a device out there that has standard user pass authentication where everything else goes SSO? Is there a system out there that's running an appliance by a vendor that hasn't updated in 20 years? So that's the kind of stuff we want to talk about today. So just quick background on kind of runZero. We help folks identify, prioritize, and reduce risk across everything, whether it's IT, IoT, or OT. So a lot of folks are familiar with the Gartner kind of CTM graph here. We focus a lot on 1, 2, 3. We also started helping out a lot more with 4 and 5 recently. So the idea is that you can get a complete inventory of your assets within minutes using the solution through active scanning, passive discovery, and integrations. And if all you have is a network port, let's say in a conference room, we can give you a full map of the organization with no credentials really quickly, no matter what. So a lot of our customers are pen testers, consultants, MSPs, but also folks who operate large factory floors or are industries that are heavy with M&A, where they're constantly bringing new clinics to a healthcare brand. As a result, they often don't have credentials to enumerate everything in the environment. So in a perfect world, you'd have an agent on everything, or you'd have some access to every device. But if you don't, well, what do you do instead? And that's kind of what we focus on. Is how do you identify, monitor, and manage all that stuff, internal, external, cloud, mobile, in the most efficient way possible with whatever credentials, whatever access you happen to have. And that's a little bit different from most solutions that look at it from a, well, step one is install your agent. Step one, step two is configure your authenticated scanners. So we try not to depend on those for full visibility. And lastly, of course, we want to help you assess, prioritize, and reduce risk by identifying things like vulnerabilities, misconfigurations, exposure. Most customers, most users, most organizations these days that care about security already have a pretty robust vulnerability management program. Vulnerability management tools are really great at telling you, hey, you've got a patch that's missing, or this device is missing a patch and it's on this particular network. What they're not so great at is identifying misconfigurations or exposures that are really more contextual about where the asset sits in the environment. Vulnerability scanners are also not particularly great about looking at your entire set of assets as a whole and identifying problems that only occur when there's interrelationships between those assets. So, for example, if you do a vuln scan of an asset and it looks great, everything's hardened, it's fully patched, et cetera, that's awesome. But what if you scan the asset right next to it and then realize they both have the same crypto keys? They have the same SH host key, same TLS certificate. Well, individually those assets look great, but as a whole, you're now seeing issues with how you're doing key management, how you're doing vuln management provisioning. So those are the type of exposures that we want to focus on in this session, and we'll kind of go into a little more depth here. So kind of first off, what's a runZero? We take all your various network data, your integration data from active, passive, and all your connectors, bring them into one place, overlay that data, make it really easy to make decisions about what's going on in your environment. So for example, you can find all your stuff. You can visualize your networks. You can respond to 0-day instantly without having to rescan. So for example, there's another vulnerability in, let's say, a Palo Alto SLVPN, and you say, great, I know about one of my Palo Altos. Do I have a backup somewhere I don't know about? Well, we can tell you that instantly. You can query the inventory and say, show me all my Palo Altos, and there you go, you're off and running. The same goes for things that we don't necessarily have a fingerprint for ahead of time. So for example, if there's another vulnerability in software like MoveIt or another file transfer program that may not have been on everyone's radar before, but it pops up as being actively exploited one day, we can help you find those assets even if we didn't know what a MoveIt was the second it came out, right? We can help you build a search query that'll search for existing data across your infrastructure and find all the assets that are running that particular software. So the idea is that we're constantly in a race against attackers. We're trying to make sure that you're able to identify exposures and fix them prior to someone else exploiting them. And we've seen the time between discovery of a new vulnerability and active exploitation basically shrinking. It's been getting shorter and shorter in the last 2 or 3 years. That combined with a lot of the attacks on edge equipment, whether it's a firewall, router, VPN, file transfer tool, have resulted in a lot of ransomware, a lot of exposure as a result. So once you get past the kind of like, here's the burning issue of the day, what we really help you out with is minimizing gaps in your security controls, identifying network segmentation issues, and helping you with regulatory coverage across the board. So for example, if you are subject to PCI DSS, you want to make sure that your CDE is completely isolated from your non-CDE, CDE being your card data holder environment. So we can do that very easily. We can say, here's an asset that's multi-home that shouldn't be. Here's a system that is not currently blocked off where it should be. And help you figure out, okay, do I actually have an EDR on all my Windows servers? Where am I missing coverage of my vuln scanner? Where is runZero reporting an asset, but my vuln scanner is not, for example, just to find out where those missing scopes are. And we do all this by making it really fast, really easy. So you can deploy through SaaS if you want in minutes. We've got a little on-prem executable. You can run pretty much anything. So any point of presence, you can throw it in a Raspberry Pi, you can stick it in a VM, you can run it on your desktop, and that's all you really need. And if you do want to do a full self-hosted install, the entire application is just one binary in a Postgres database that installs in your favorite version of Linux. So again, you don't need agents, you don't need credentials, you don't need appliance. I just need some place to install software somewhere in your environment, and you're good to go. So we really pride ourselves on having a solution that is simple, that's fast, that's easy to install, and that you can kind of work with it as any other tool. The biggest challenge with unknown assets is that they tend to be the place where your security team has not been focusing their efforts. So if you have a really good security team, there's a joke in the industry that security teams tend to be 1 to 3 people or 30 people, depending on what breach happened. And we still kind of see that as a truism, at least as far as larger orgs. Once folks realize that we don't have a good handle on security, they make lots of investments. They bring in tools, they bring in teams, build in processes, they build out their NOC, they bring in third parties to help with monitoring. But if they don't know about something, they can't really help you protect against it. And it's incredibly common for us to work with customers where we're finding net new assets that aren't on the map of the IT team, the networking team, or the security team. And it's really easy to miss them, especially when they're things like unmanaged devices. Like your IT team cares about things like, is the server running? Are my backups good? Are my endpoints functioning? They don't necessarily care about like, is the firmware of this Netgear router in the corner being patched? or what is this random vendor device that's sitting in the corner that handles like our alarm system or HVAC. So a lot of those unmanaged assets really do fall off the radar for IT teams, and they're really up to the security team to say, hey, this is something we need to care about, or we need to isolate. And endpoint protection isn't enough if the rest of the infrastructure is basically exposed. So just on average, our customers find about 25% more assets with runZero, even if you've done a full deployment for a typical CASM product with integrations and agents. The reason for that is like oftentimes there's no individual managed device in your organization that you can ask that will tell you about the unmanaged devices. So for example, you may enumerate like maybe the switch S&P table to identify what assets are connected, but what if there's another switch beyond that? What if there's another hop beyond that you don't see? So it's really easy to lose track of assets, and unless you actually go look for them, either through like passive discovery or the active network crawling that runZero does, it's really hard to find that stuff and bring it back onto the map. And of course, that's where all the problems are, because if you don't know about it, your IT team probably doesn't know about it either. No one's patching it. It's probably running out of sync. It's probably missing your configuration changes. Those tend to be the kind of the sore spots in a lot of networks as a result. So I kind of mentioned that 25% tends to be the most vulnerable, just because they're not being tracked. They're not part of automatic patching. They're not things that people are otherwise aware of, and they're often missing your security controls, whether it's EDR or vulnerability management as well. And oftentimes these are tied to critical functions like door access controllers or tape library robots, things like that. They tend to be the stuff that's really difficult to manage, even if you know about it. Three categories of visibility that they fall into. You've got kind of, in the kind of gold box here, your high visibility assets. These tend to be your endpoints, your servers, stuff that, most of your team's really aware of, that you've already installed, an agent on, that you've at least got some good security controls around. You've got some way to kind of influence them or lock them down, otherwise harden those devices where at least you'll get an early warning if something bad happens. The next category are those that you may have only moderate visibility into. They could be things like smart TVs, wireless access points, printers. Sometimes you have S&P management. Sometimes you've got some sort of vendor management tool that help you keep track of it. But oftentimes there's not a lot you can do with it. Like if the vendor doesn't put a patch out, well, you can't patch it. So hopefully they're keeping their patches up to date. Or if there's a configuration flaw and you're not aware of it, like you need someone who has like very specific knowledge of that device to help you lock that down and apply those configuration changes. So a lot of the network equipment, a lot of your periphery IoT stuff tends to fall into this category. And then lastly, you've got the stuff that no one knows about. Everything from like the random thermostats to a rogue camera someone sets up in a building that no one really knows who installed it. The fish tank that was famous for being used as a hot point to break into a casino. All that kind of stuff that really, there's nobody who's in charge of owning it. It just happened to be somebody plugged into the network or hooked up to the wireless and forgot about. One of the challenges with most kind of scanner-based fingerprinting or scanner-based discovery is they don't really tell you a lot. It's really common for a vulnerability scanner to give you a great list of vulnerabilities, but then give you a terrible detail about what that asset actually is. So it'll say you've got a Linux device with these vulnerabilities, but it'll say product Linux, vendor Linux, or maybe Linux 3.2 to 4.9. What runZero does is we focus a lot of our effort on fingerprinting devices so precisely that we can tell exactly what it is. So no, it's not just Linux. It's Linux running a TrendNet IP camera with a particular product model. And in this case, it's sitting on the factory floor. So if you just had a list of assets and someone gave you a list saying you've got a Linux server, it's like, okay, I probably have some Linux stuff there or whatever. But if someone comes back to you and says, hey, you've got an IP camera on this floor, you're like, there should not be a camera there. That's, we use access to, this is a TrendNet, or this is a sensitive environment, there should not be a camera in that room. So it's that kind of context is really important for knowing whether something shouldn't be there in the first place or something's misconfigured. But if you look at just a list of vulnerabilities or just a list of OS information, you're not really going to get enough context to make that decision about whether it's something that's important or not. And we help folks with this all day long. This is kind of the bread and butter of what we do. So, what do you do when you've got assets that you can't really secure? Well, the most common fallback is to put them into their own segment. So the idea is that, we isolate our trusted stuff into one box, our less trusted stuff in some other boxes, hopefully not too many untrusted things in the same bucket. And that hopefully limits the breach radius, the blast radius of a breach if one of those devices is compromised. In the case of things like PCI and other regulatory requirements, it also helps you reduce the scope that you have to worry about. So if all of your card data holder environment stuff is in one bucket, well, you only have to apply some of the PCI rules to that particular bucket, not everything else in your organization that doesn't necessarily have the same security requirements. The challenge of the segmentation falls apart all over the place. I would challenge you to find a single device in your organization that doesn't have at least 2 IP addresses. And what you're going to see is nearly every device will have IPv4 by default, typically DHCP, but it's also going to have linked local IPv6. and those are completely separate. You can have a firewall in v4 that's not in v6 and vice versa. It's really common for us to find a vendor-shipped appliance where the v4 side is locked down, but maybe Redis is exposed without a password on the v6 interface is exposed to the local network. You're also seeing things that developers love to use containers, and unfortunately, the container stacks they actually enable IP forwarding by default. So effectively, everything becomes a router almost by default. If you have a Linux laptop running Docker, oftentimes someone on the same network can then use you as a router to route to segments that they otherwise couldn't access. So if your Linux laptop, or sorry, your laptop's connected to Ethernet on the wired side and wireless on the other side, theoretically, an actor on the wireless side can then route through your laptop to the wired side. And it depends on the configuration, of course, but we see that happening all over the place. And typically, all you need is one extra link to kind of break your security model, because you assume that all the sensitive stuff is in one bucket over here. You have to be absolutely sure that there's no cross references or links between those assets. And it's really difficult to verify. If you have an agent on every system, that would help. You'd at least see what software is installed, list IP addresses. But for things like network equipment, your printers, things like that, they're really difficult to verify, and they're really easy to misconfigure. I'm not even sure you can buy a printer these days that doesn't have at least 3 network cards in it. Typically, every printer you buy off the shelf has a wireless card, a Bluetooth, and Ethernet these days, and sometimes more than that with some of the other LoRa and other kind of new protocols that are being launched. So an example of what this looks like in the real world, here on the left side, we've got a blue box. This is kind of your standard corporate environment, your databases, your servers, your endpoints, things that are supposed to be fairly secure. And on the right side, you've got your wireless guest network. So unfortunately, an attacker could connect in, let's say from the parking lot, connect to your printer through wireless, through the built-in access point, use that to then route into your wired network, use that to then start attacking devices in that network, like let's say your access point itself. In a lot of organizations, your layer 2 and layer 3 devices, they're not just devices you need to secure on their own. They're devices that actually control your segmentation. So a fun trick that we've used in pentest land is to steal the credentials to the network equipment and then carve our own holes through the firewall to get the network we need to. So for example, if you find SolarWinds box running Orion, you can dump the configuration out of that system, use the credentials from that, then take over the ASA, reconfigure the ASA, and then carve a hole directly into the PCI environment. And that's how attackers do things. They find the easiest route in, and if the easiest route in is to take the credentials off another box using to manage the network equipment and then break through the network equipment, that's how they're going to do it. So these types of exposures are really common. Another kind of fun view of the internet, and this is one that is always kind of a head scratcher for me when I first saw it. This is the Shodan favicon map, and you can go play with it yourself at favicon map. That's shodan.io. It's really fun. So effectively, they take the 5,000 most common, favicons, those little bookmark icons you see in websites, and they put them onto a big graph here based on how commonly these are seen externally. Now, some of these would make sense, right? The kind of red circles down here, you've got Fortinet, so lots of Fortinet firewalls, SLVPNs, gateways. That makes sense. You see you see Outlook Web Access, you see some Cisco gear, you see Plex servers. Like, okay, those all make sense to be externally exposed. Down the left here, we see an OpenVPN icon. But what are the things that jump out that really should not be externally exposed but are? And then why are those exposed, right? So if you have any thoughts, we'd love to see your suggestions there. But just to kind of answer the question here, you'll notice a lot of these have these kind of big round circles. These are all camera icons. So what's happening is that a lot of customers are installing home security cameras, whether it's Dahua, Hikvision, an off-brand one, or maybe a US brand like Amcrest that's really using Dahua under the scenes. And those devices automatically cut a hole in the firewall for themselves and port forward the admin traffic in. So for example, if you take an Amcrest video camera and you plug it into your home network, and your home network is connected to, let's say, the home router provided by AT&T, by default, your camera is going to open up those ports for remote management and for remote video access through your firewall and expose to the internet. And the size of this icon indicates that this is really common. Now, if you're security savvy and you disable UPnP in your firewall, that's great. You're not going to have that problem. But for folks who just plug things in and expect them to work, we're seeing a lot of default exposure. And this happens not just in home networks, but also in corporate environments. If you have a backup line, like let's say a DSL modem hanging in the closet, that DSL modem from the vendor may have UPnP enabled by default. And you may have a device in your network automatically carving holes right back in. So it's that kind of exposure we want to highlight today. Things that are unexpected, things that are like your network team doesn't know about, things that are otherwise not quite malicious, but definitely unexpected in terms of how network devices are reconfiguring themselves to enable external access. So when you talk about external attack surface management, a lot of folks start off talking about external. So in the old days, we called that the hard crunchy shell, the candy shell, and then you had soft gooey center. But these days, your external attack surface is everything. It's internet-facing servers, random IoT stuff, it's your cloud stuff, it's your VPNs, it's your firewalls, it's your file transfer applications. It's all this stuff, right? And with the 2024 Verizon DBIR, 83% of breaches that they defined were all coming through an external attack vector. So we know it's really important to secure your external attack surface. There's an entire industry focused on making really good external attack surface tooling and discovery, and that's great. But it's not the full picture, right? When you start looking at what's inside the company, we're also seeing massive sprawl across internal networks. It's no longer, if you asked folks 10 years ago what was going to happen in internal networks, a lot of folks would have said, well, it's all going to go to the cloud. That's great, except for, you can't go to the cloud when you're going to the doctor's office. They still need a computer to write your info. They still need to have, lab equipment. They still need to have, x-ray equipment. So all the stuff you need to provide whatever physical services that your organization does is not going to the cloud anytime soon. There's a famous chicken sandwich shop that has Kubernetes clusters in every single store. And that's something a lot of folks don't think about. Like, why would a fried chicken sandwich shop have Kubernetes? Well, they can't depend on the cloud being available. So as a result, the internal network for both home users and organizations is getting a lot more complicated. And every one of these vendors wants to make their device somehow externally exposed. You see them either trying to make it available through the vendor portal, you see them carving holes into the network through UPnP. But it's pretty challenging to keep up with this stuff. And on average, our customers see 20% of their internal assets not on their map before they use their product. So effectively, they find 25% more, which works out to 20% less. But that's the general stat. So do not be surprised if 1 out of 5 systems that you actually have is something that's not currently in your vuln management scope or something that you're otherwise tracking. Now, where things go wonky is when you have easy access from, let's say your external attack surface, which anybody on the internet can reach, to something that's really important in your environment. There's a great study that said, 60% of all compromised external assets are just one hop away from an internal system, a critical internal system. And we can do segmentation, but segmentation doesn't get you that far. At some point, your database has to be, connected to by your application, and your user has to talk to your application. So there's only so many hops you can have in some cases between where your critical data is being stored or your processing is happening and where users and often attackers can start to influence it. I mentioned before that internal networks getting more complicated. A lot of devices are carving their own internal or external routes into the environment, and this is causing a lot of challenges with external attack surface management. So even if you know all your IP addresses, all your domains, you're looking at your cloud inventory, you're constantly loading all your cloud data into your environment, that doesn't help you if one of your devices starts calling out on a IPv6 address, uses the VPN, or otherwise exposes itself through a mechanism you don't know about. And if you do an internal scan, you're not going to see that either. Oftentimes, all you see is vendor traffic going out to, encrypted traffic going from a device to a vendor's portal, not knowing that it's actually doing, let's say, a full port forward, or it's doing like a full IP tunnel backend. And this is a lot more common than a lot of folks think. Like, for example, the Plex forwarding tool. The Plex forwarder actually just runs SSH, and it runs SSH to a Linode box using user and password, and then forwards the port back into the local device. So effectively, if you're using a tool like Plex internally, there's something like 400 odd servers on the internet that have a port forwarded SSH connection back to your device and back to your server, which is not great. So just examples about how this stuff can go wrong. In this diagram here, we show that we've got a thermostat, another IoT device that's exposed through vendor VPN, which then can be used as an ingress point into the servers, into the internal network, and eventually into your dev environment, from there into your actual data center and your code. So these attack paths can be pretty hard to find. And that's what we want to talk about today, is how do you find these other attack paths that don't show up tied to your domains, they don't show up on your internal agent installations, that your EDR is not going to report them. How do you find these kind of oddball side connections? So we are seeing internal environments kind of change even faster than ever. You're seeing all kinds of fun stuff with V4, V6, tunneling, all kinds of fun port forwarding and kind of network hijinks. Overlay networks like Tailscale are becoming more popular. VPN products being baked into every web browser, let alone every mobile device. So the amount of interconnectivity you have is just getting ridiculous. If you have a Mac OS laptop and you type the command ifconfig, it's pretty illuminating how many different network interfaces are on by default. It's something like 16. It's crazy. And the second you plug your laptop into, let's say, your Remarkable tablet, all of a sudden you've got yet another network interface. And you're like, well, why do I now have a 10x IP address on my laptop? well, ends up, even though your remarkable tablet or other gadget you're connected to has connectivity through Wi-Fi, it's actually also set up an Ethernet gadget on the USB cable. So the amount of network connectivity that we're seeing at the individual device level keeps spiraling up, and the interconnectivity across these devices gets a lot more complicated inside the network. So the kind of fun trick we're going to talk about today is that you can actually use the really precise fingerprinting that runZero does to do more than just device fingerprinting. So for example, if we can identify that an asset is, let's say, this IP camera, this trend that we talked about before, and we can also figure out that it's got this IPv4 address and it's got this IPv6 address, and we can figure out the fingerprint of its SSH host key or maybe its TLS certificate, we can now use that information to go scrub the whole internet and look for, okay, is that V6 address actually reachable from the outside? What other devices in the whole world have that exact same SSH host key? If it's only one and it's not a widely shared key, well, this device is probably publicly exposed in that IP address. So that's the kind of tricks you can use. You can basically use the fact that you've precisely identified an asset to then look for anything else in the whole world on the public internet that has that exact same unique identifier, and then correlate the two together and figure out how things are connected. You can often use indirect queries as well. So for example, if we see a Chromecast device on the network, you can actually query the Chromecast device and ask it which Wi-Fi SSID it's connected to and what BSSID it's connected to. Then you can then pop that BSSID into something like wiggle.net. You can then pull up a list of where it physically is located. You can find other devices in the same area as it. So there's a fun attack in the news recently about, I think they call it like a nearest neighbor attack, where a threat actor was able to compromise the wireless equipment or PCs basically of a neighboring organization and use their desktop's wireless connections to then attack the real target. So that kind of stuff is not just science fiction, as we saw in the news, but also it's fairly doable when you start pulling these different identifiers out of your internal network. You can then start looking for them elsewhere. So that's the general gist, is that if we can precisely identify an asset to the point that we know exactly that there's only one of these things in the environment, and then we also see that same asset externally, we know that it's probably externally exposed. Another really neat trick here is that you can actually often ask an asset for its list of IP addresses. So every Windows asset, every Windows computer by default will tell you its IP addresses two different ways, not just the ones that you're talking to directly on the local network, but its secondary IPs. So if you have the NetBIOS service of UDP running, for example, you can actually ask it for first its name, and then using its name, ask it for a list of all its IP addresses. And then it'll come back saying, okay, all our IPs are A, B, C, and D. So that's a really quick way to find external IPs you didn't know about. For example, a VPN adapter, a mobile LTE card, a basically second route out of the environment that you don't know about. The other really useful trick that's on Windows is you can connect the DCRPC service on 135 TCP and call what's called the OXID2 resolver function. That'll come back with the host name of the machine, but also comes back with the IPv4 address and the IPv6, which you don't get out of NetBIOS, but you do get out of DCRPC. So by default, every Windows computer will tell you all of its IP addresses if you just ask them, but very few tools actually do that. And that's something we built in runZero really early on. So if we're able to convince a Windows machine to tell us that it has multiple IPs, we can kind of trust it. We can say, okay, you said you're in this network and you said you're in that network. Well, we know that you're there. We know you're connecting those two networks together. You're effectively a network bridge. Or, hey, one of your IPs is external and the other one's internal. Like, that's not great. You're now being exposed. You can have an internal machine directly exposed to the internet. So effectively, you can say, first, give me a list of all the IPs that the device knows about, or use one of many different tricks to figure out what its secondary IPs are. Then you can also say, for this given unique fingerprint, where else do I see it in the network? If you see the same unique fingerprint, let's say for this camera in 3 different networks, well, it may actually be on 3 different networks. It's either 3 cameras or it's in 3 places at once, right? So if you see the same fingerprint in multiple places, it's actually bridging multiple networks together. So you can take that approach kind of at scale. So in runZero, if you go to the reports tab and you click on layer 3 bridge report, you'll get a graph kind of like this. So this is a network with just about 100 employees on it. It's pretty small. But there's already 2 different internet ingress points into the environment. One of them that is expected, that's the normal router. And then you've got another asset deep inside the core network that has a LTE card plugged into a laptop that's externally exposed and directly reachable. So straight RDP from the internet on your internal network, and no one's the wiser. And there's really nothing you can do in the internal environment to identify that because that communication goes out through a secondary network card, in this case, the LTE card. As you start scaling it up, though, it gets even more difficult. You can see even with 300 employees, the cross connections just get so messy that it's hard to pick out even a single point of ingress here. But just kind of skimming this, you can see there's probably about 15 different ways from the internet into this organization, outside in, that don't include the firewall, that don't include the primary egress point of the network. So those are kind of exposures that we think are really important for folks to identify and to address. And we're going to go into kind of like how we do that here. So We mentioned that we create these really precise fingerprints for every asset, and then we're able to use that unique fingerprint to then scour the whole internet looking for the same one and then match them up. So if we see a unique fingerprint for a point of sale system, an IP camera, even like a Windows laptop, we can then say, did we ever see anything with those same attributes on the internet? So there's lots of different attributes you can look for. We've got a whole stack of cool, neat ones that we build up. There aren't just things like TLS fingerprints. It could be TLS fingerprint plus host name. It could be the serial number of the RDP service. It could be some information you can leak out of the SMB v3 pre-authentication. So we use a lot of these really deep protocol tricks to get these unique identifiers per asset. Then we look at the entire internet saying, okay, is this a identifier that's commonly shared? If so, that's a problem too. And if it's not commonly shared, does this indicate that a customer asset is externally exposed when it shouldn't be? And we see lots of cases of both. And so we'll hop right into the demo here to talk about that. So if you haven't used runZero before, it's pretty straightforward. You can sign up for an account online, runzero.com/try. When you first log in, you'll be prompted to bring some data in, and there's a few different ways you can do that. You can run a scan. So if you want to run a local active scan in your local segment, probably the fastest way to get started. You click Deploy and Explorer. It'll walk you through like picking OS, a version, architecture, etc. You can run these things on anything. So you can stick it on Linux, stick it on Mac, ARM, MIPS, PowerPC, S390, almost anything else in between. If you really like OpenBSD, we run on that too. So everything from Windows desktops to Linux to Mac, it's really easy to get started. And once you've got one Explorer installed somewhere in the environment, then you can start doing things like active scanning. You can do passive sampling, where you just monitor the background traffic of the segment, or even like point an entire scan port tap at that device. And lastly, you can then do integration. So if you want to connect to something like Active Directory, pull data in from Census to Shodan, connect your EDR through CrowdStrike or SentinelOne, connect to Defender, connect to Google Cloud, AWS, et cetera. You can start bringing all that data together and then overlay it all together to get a better picture of what's going on. So in this environment, I just imported some of our cloud data as well as an active scan of the runZero external space. To show you what it looks like, we're just going to standard scan real quick in the discovery scope. If you know your IP ranges, you can use that. If you want to use your ASN number for whatever number you happen to have, you can use that as well. Or you can just be easy and say, I want to scan runZero.com. So you type in runZero.com, hit initialize scan. It'll come back with a list of all the different host names that it's found so far. You can then kick that off. It'll run the full scan. And you can configure that scan how you like. These scans are safe to run at pretty high speeds. If you're in our SaaS environment, you can actually pick a hosted zone, which means we run the scans on our infrastructure. You're more than welcome to run it on your infrastructure or run it self-hosted as well if you don't want to do that. And you can go through and configure the scans in a million different ways. You can do subnet sampling. So if you want to crawl an entire RFC19 like 10/8 overnight, you can do that pretty quickly. If you want to change the TTLs, if you want to kind of limit your blast radius of how far your packets go, that's a quick thing to change over here. And then you can also precisely configure every single type of probe we send. So you want to override what port we probe for, the brother printer protocol. You want to fiddle with how we do Crestron discovery. It's all pretty much open book here to play with. If you do have credentials like SDB communities, you can plug those in here as well, or VMware credentials. We'll use those kind of opportunistically to get more data about the environment. And of course, we'll try like public and private by default in the environment as we go. So all said and done, if you want to scan, you would a list of assets. You'll notice right away that our definition of an asset has more than one IP. So for example, the console runZero.com asset here has 2 v4s and 2 v6s. And that's normal. Like it's normal for an asset that have multiple IPs. It's also normal for an asset that have multiple MAC addresses. So it's not a one-to-one of asset to IP by any means. IPs change all the time. Every time you have a load balancer that is in Amazon, for example, it's going to change at least one of its 4 IPs every couple hours, and it's constantly cycling through IPs. So runZero keeps track of that, deletes the old ones, adds new ones, et cetera, to go through it. So once you have a list of this stuff, in this case, we also pulled in the cloud data, so we have a little bit more metadata about the instance size, things like that. You can start digging into it and say, okay, well, what's the weirdest thing looking in the network with the outliers? Well, we've got one device here that looks like an outlier. It's running different OS and everything else. You can also do things like break it down by what hardware, what are the different virtual machine types we have most commonly. And anything in the UI here can be both searched and pivoted on. So for example, if we want to go look at, let's see, the VPC ID, we can get a breakdown of all the unique VPC IDs within the organization. In this case, just one, and there's 6 assets in this VPC. So it's really easy to kind of take this approach to kind of slice and dice and pivot your data to figure out what's out there. So an external discovery scan, external perspective is pretty straightforward. You can then look at the services, say, show me everything running on a high port, low port. Here's everything running in port 880, everything with TLS, everything with SSH. There's tons of built-in queries. So you can have a query saying, show me anything that's RDP and publicly exposed, show me anything like, oh, your kind of standard external exposure management stuff is kind of baked right in. And of course, you can load in your vulnerabilities, and we take screenshots for the scan as well, so you can see kind of what the device is just based on that. Let's see. So the external side is pretty straightforward. It's kind of standard. It's what you'd expect if you wanted to plug in some IP ranges and or domains and tell it to go discover stuff. We'll show you kind of everything externally facing in that sense. And of course, you can overlay your cloud data and other connectors on top. So if you have a tenable scan, you can overlay your tenable scan on top of that. You can overlay your AWS config, GCP config, et cetera. And we basically match them together based on that. Now, what I want to focus on today is a little bit different. It's the internal side of things. So if we go look at the internal side of the network instead, it's a lot juicier, right? You see a lot more details, a lot more unique types of devices. We've got the networking equipment, we've got network management stuff, we've got all kinds of fun things like virtualization. If we sort based on the outlier score again, which is our way of saying how weird a device is compared to its neighbors, you see stuff pop up to the top. Like, what are the least common devices in the environment? What are the things that are probably most useful for a defender to focus their time on? It'll be things like your NAS environment, it'll be like your cloud key controller, which controls all your APs. It'll be various IP cameras that are probably running older, dodgier operating systems and firmware. And you see we're able to do a pretty good job of fingerprinting everything from like your Google Home Minis, audio assistances, all the way down to like more of your enterprise assets, like your Windows servers and so on. So if we go pop over to like this Windows server, for example, we can see that we actually flagged this device as a Wi-Fi card installed, even though we didn't actually authenticate to the device. In this case, CrowdStrike was installed as well, but it's actually not how we identified it. So we're able to say, okay, this device actually has MSSQ running, it's running network policy servers, running root desktop gateway, and we do all this just on the EPM side. And we also identify that it's got the wireless WAN service running on it remotely, again, without credentials, and able to say, hey, this device has a wireless link. So if you're in an environment where you really should not have any laptops with wireless card enabled because you're in wired only mode and your security controls effectively state that you should not be using wireless, just go and look for this wireless adapter is a quick way to find devices that are out of policy. So search for EPM Wi-Fi true, and hey, you've probably got some devices here that are using Wi-Fi when they should not be. There's also a EPM WWAN parameter, which it's not going to find any results in this particular environment, but this will identify cases where mobile LTE and cellular cards are installed in devices. And you quickly get a list of all the devices in your environment that are running Windows that have a have an LTE or cellular internet card connected. And that's another way where these devices can basically evade your egress monitoring and your network monitoring because they're going out to a different link than you expect. And just like the external side, you can look at all the different services, say, like, show me all the interesting stuff, show me everything that's, let's say, running on port 22, hopefully just SSH daemons. You can also say, show me everything where the protocol is SSH, the port is not 22. So are there any SSH daemons running on a port? Nope, not. But that's how you can find things like your like Jenkins SSH control ports, things like that. So really easy to find things that pop up right away that really shouldn't be there. So we talked about kind of doing kind of your kind of top level external exposure management, your internal discovery through scanning, through integrations, through passive monitoring. Next, I'm going to talk about a little bit is how do you actually go about identifying devices that are externally exposed internally? So kind of the focus of this presentation is that once you have a really good internal inventory, you can then use this to do a really good external inventory. So for example, we can go look at, let's say this, we'll find a camera here to look at real quick. Here we go. This is a high K vision camera. We're gonna go eyeball it real quick and take a look at the attributes we get. So we got one IPv4 address, we've got an IPv6 address down here that has MAC embedded in it, host names, things like that. We dig down into the attributes real quick, though, you'll see, okay, it's got an SSH daemon running on it. It's got this specific SSH key. Now, if we find anything else running the SSH key, it's going to be one of two things, right? Either this device has a shared SSH key where every device made from this manufacturer, this firmware, has the same key, or it's a case where this device is being externally exposed with a carved hole in the firewall and port itself through. And those are both pretty common. So we can then do a search for this key across the entire internet, say, does anything else match this key, and then come back and flag this device as being exposed. Or if we see 1,000 devices with this key, then we know that this device is running a shared crypto key, and that's also bad. So when we talk about this having no false positives, that's what we mean. Either way, if you get a hit on one of these, quote unquote, unique attributes, you've got a problem. If there's only a couple hits, it could be the device is directly exposed to the internet. And if you get a lot of hits, it means your device is using a shared encryption key, TLS key, host key, which is also something you want to do something about. So if we go over to our vulnerabilities tab now, you see some cases where we're able to do that. So in this case, we've got a hit for a compromised key TLS. We pop over to this particular asset, we mouse over it, and we say, hey, this asset is using TLS key 299, et cetera. This actually matches a Raritan PDU hard-coded TLS key in the firmware. And the mitigation, of course, is to rotate the key. So log in, generate new cert, replace it, et cetera. So these are really common. This one is, it's not a huge vulnerability in the sense that no one's going to directly break into the asset because it's got a shared crypto key, but it means TLS is not TLS. It's effectively just telnet. Someone can actually man in the middle of that and then use that to basically hijack your credentials and take over. So this one, while scary, is not the end of the world. So we're going to go look at the other kind of vulnerabilities. So in this case, now we see an example of internet exposure TLS. Now for this asset, this is actually one that surprised me. So this is just a pet box that I run that has like some camera controls, things like that I do at home. So this is actually my real home network here. And I did not expect to see 2 hits. Like I thought I'd see one of them. So this device runs internally and it's forwarded through my firewall so I can get to it from outside. So I can control, the cameras and things like that from outside the house. And it's got authentication, things like that. So it's not super secure in that sense, but it's also not just wide open. But so I expect to see like being exposed on at least one external IP, like probably my Google Fiber Home IP. I did not expect to see it exposed on 2 IPs. So I'm trying to figure out like why is there a second public IP that has my exact TLS cert for this internal thing that should only exist in one place? Well, ends up a long time ago, I had Spectrum as a backup internet provider, and they kept raising the rates. And I already bought my own modem, and I was like, you know what, you guys are going down more often than Google. I don't need you as a backup if you're not going to be reliable. I went ahead and basically terminated the contract there. Well, ends up they never terminated service. So even though I've not been a Spectrum customer for some time, the interface is still wired up to my firewall. My firewall is still forwarding traffic in from it. And this inside-out attack surface management feature that we're working on was able to flag that the Spectrum IP is another way into this particular environment. So that's just kind of a home lab example of how this stuff works. But real-world examples that I can't show because they affect actual customers are things like remote desktop being exposed to the world, where we can fingerprint the remote desktop TLS cert, serial number, all the unique bits that are part of the remote desktop interface. We can then identify that on a random internet-facing IP address and say, hey, your internal desktop is being exposed somehow. And so we're working through notifications for customers in cases where we've identified that. Another really common case we run into is where you have maybe a gold image internally. So let's say you create, your baseline configuration for Red Hat 8 or whatever OS that you want to use for internal servers or deployments. When you create that image, oftentimes folks forget to reset the SH key or reset the crypto keys before basically baking the image. Now, anybody else who creates a copy of that image is now also getting the same crypto key. So it's not a huge thing. It means your SH or TLS isn't particularly secure because anybody who compromises one node can compromise the rest. But where it starts to get a little more dicey is when one of those devices starts getting exposed to the internet. So there's an example that I ran into this morning where a customer had 200 devices inside the internal environment that all had the same SH host key. So, not great hygiene, but it happens, not a big deal. But then we also found one of those on the internet. It's like, well, okay, how did this internal dev-only image get put on the internet? So that started a whole chain of investigations trying to figure out, okay, well, why is it on this IP range? How did it get forwarded through? The IP range not even associated with the customer. And, long story short, it was a developer running that VM and port forwarding it into their home lab, into their home machine, basically from the internet. So at this point, now there's a internet-facing path into one of these corporate gold images. If someone is able to compromise that system, they can then take those crypto keys off the box and they can then ban the middle all the future traffic. And of course, that's probably the least significant thing that's on there. The most significant stuff would probably be source code, credentials, things like that. So anyways, that's the idea here, is that you can use the unique attributes of a given asset, whether it's the TLS certificate, the fingerprint of the remote desktop service, things like the SWV3 engine IDs. And if you find a small number of hits of that same identifier on the internet, then it's probably exposed, and you know exactly what IPs it's exposed on. In this case here, 47.234 and 136.49. And if you see a ton of hits across the internet for the same unique identifier, it's also a problem because now you're using shared crypto keys. So we'd like to say that 0 false positives, but really it just, you pick what side of the coin you land on. But either way, it's something you typically need to do something about when you find it. So this feature is actively in the works right now. We're hoping to get it out this week to private preview. We're still going through and trying to figure out how much of that tuning we can do ahead of time so customers aren't going to get a big list of things that aren't relevant. But just with internal testing so far, we found a lot of exposures that really could not have been found in either way. So a lot of our customers have very robust vulnerability management programs. They have great external attack surface management, looking at everything they possibly can be looking at, and yet we're still finding inbound routes into their internal environment through multi-homed internal machines with like LTE cards, external V6 gateways, and things like this, where there's an unexpected path into a device that you can only identify by looking for that particular unique identifier. So with that, let me switch back over and check the questions.
All right. Are we, Isha, you ready to go to Q&A?
Yeah, sure thing.
All right, good. Let's do that. Before we do that, I just want to remind everyone about the webinar survey. I mentioned it earlier. It's available on the bottom of the presentation window, and we hope you'll fill it out before you leave us today. Your participation in this survey helps us to improve these events in the future. Let's do Q&A. It's not too late to submit a question. You can just type it right into the text box that's at the right of the presentation window, or click the Q&A icon, and we'll do our best to get to everyone's questions. Let's take a look at what we've got. Okay, oh, we've got quite a few questions. Great. How about this one? How do you discover organizational technology through cellular or non-corporate network connections? Does the solution offer a way to follow the connectivity and determine potential threat vectors from OT to IT?
Yeah, good question. For the operational technology stuff, our active scanning is safe for OT. So we can do it just like we did with DCRPC on Windows desktop. If you have a HMI platform running Windows, oftentimes we can convince that machine to tell us its secondary IP addresses, which will indicate here's the the link back to the OT vendor through a VPN. We can see that VPN and IP address directly in that case. Through password discovery as well, you can often see little bits of traffic that leak out. So for example, you'll see a device doing a DNS lookup for an external name, but then never connecting to it. You know it's doing a local DNS lookup, but then its outbound traffic must be going through something else. So just by the fact that it's doing a DNS lookup, you know that device has some other type of connectivity because you're not seeing the follow through of the outbound connection. So it's a little bit different. It's not necessarily like an NDR where you're trying to put something kind of inline to sniff all the traffic. It's more of a thing where you try to take lots of kind of small samples of data from the asset and use that to identify that it's externally exposed. For OT in particular, it's really common to see devices that are hooked up to these little OT industrial gateways. So you'll see like Digi International, Moxa, things like that. And we find those things on the internet all day long. And the hard part is trying to figure out which customer they go to because they're often connected to a cellular link where there isn't like a whois you can do on the cellular link that tells you anything other than the telco provider. So it's really hard to go then bring those back and figure out which customer is affected by it. And that's where this unique fingerprint comes into place. If we can find a unique fingerprint for, let's say, a Moxa serial port server on the internet, and we see the same one through an internal discovery through an internal scan, we know it's the same device and we know that it's exposed, and we can tell you about it really quickly.
Great, okay. Well, runZero is mainly security, but someone's asking, could we use runZero as an inventory system and or inventory auditing? Do you have any customers doing that?
Yeah, absolutely. We started off being mostly an inventory system. Then we realized that inventory is such a critical base for all your other security stuff that we just have been building on it since. But yeah, inventory is what we do all day long, and we should be the best platform you have available to get an inventory with any level of access you have.
Okay, good. Here's a sort of a technical question. In your topology, where is the object place to capture this information? Is it IPS or IDS?
Yeah, sure thing. So there's a few ways to do it. You can either import data from a third party. So if you use Meraki, for example, we'll connect to your Meraki cloud. We'll pull in all your topology from Meraki. We'll show that to you in the UI. But we also do active scans. That active scans also include SNP enumeration of all the standard V2 and V3 MIBs for the CAM table, the ports, the ARP cache, things like that. So we can build topology through active enumeration through SNP by doing some password discovery of things like CDP, LODP, as well as through connecting to third-party integrations like the Meraki backend.
Great, thank you. All right, next question. Can you clarify, is runZero classified as a SIEM tool, or does it serve a different purpose within attack surface management?
Yeah, sure thing. So the SIMs tend to be kind of where you pump all your data to for doing their analytics. Our customers use this in both places. So it's really common for customers to use this as the main console for security operations. So there's new vulnerability in an SLVPN product. You need to find it quickly. You go straight to runZero, you do a query, and you're done. It's super fast, super quick. You can, really, really easy to action that. Later on, let's say there's a breach, and you want to go figure out what was running on an asset, what was near that asset at a given time. Well, you can take all the runZero data, pump all that into your SIM in the back end, and then do correlations against that data. So every time there's a refresh of your runZero inventory, pull all that into Splunk, and then do Splunk queries to tie that together and say, okay, we know the bad traffic came from this internal IP. Here's what the runZero fingerprint for that IP was. We know it was this particular camera, this particular device, this particular laptop. And that lets you kind of go back in time and do a little bit better job of kind of tracing the breach's path using that. So we're not a SIM by ourselves, but we definitely do feed data into SIMs.
Very good. All right. Next question. I'm wondering, how do you support a segregated network to the Purdue model proxy?
Yeah, sure thing. We've got all kinds of fun ways we've done it. So we support a standalone console. So we license by assets. We don't care how many installs you have. So you can put one into one level of Purdue, another one to a different level. You can have one corporate. You can build internal proxying for that. We support overrides for connectivity internally. So you can tell your Explorer or effectively our on-prem component to connect through whatever chain of proxies you want. And in one case, we have a customer who literally sneaker nets it. They collect all their data on their Purdue level 2. They put it on a file share, and once a day they copy that file share to another network, and then they import all that data back into the runZero SaaS. So it's really up to you, but our data format is just a compressed JSON file, so it's really easy to move things back and forth.
Great. All right. Next question. This is an interconnectivity question. Can I also supply runZero with Cisco SNMP to inventory L2?
Yep, absolutely. So we'll do the full layer 2 inventory through scraping out the ports table, the ARP cache, things like that. We also pull the system description, serial numbers. Some of our customers will use the runZero export for doing like warranty checks as well. Since we already have all the serial numbers of all your Cisco's, you can export a SNTC report, upload that to Cisco, and have a really quick yes or no, do I have full warranty coverage of my equipment as well.
Great. All right. Next question. This has to do with historical data. Do you maintain it? And if so, for how long? Can I keep up to 7 years worth?
Sure, lots of ways to do it. The default in the product is to keep about a year. I think the default's 1 year. You can go up to 3 years of historical stuff kind of built in, but it's really easy to archive off. Effectively, any job that you run in the product can be exported back out as raw data file and archived, and you can also take those archives and reload them back in. So if you wanted to, let's say, export your tasks every so often and then take data from 7 years ago, load that into a fresh environment and runZero, you can kind of go back in time and look at what the network looked like 7 years ago pretty quickly. We also provide some diffing tools, so you can go back like 6 months ago, grab a tool or grab a scan, compare that against your current one, and show what's changed.
Wow, that's great. Okay. Next question. How do you handle legacy systems and shadow IT? You talked a little bit about this, things which might not be as easily fingerprinted. How do you handle that?
That's a good question. So the fingerprinting we focus on is really about how do we identify those things in the first place. So oftentimes, like one of the cool side effects of building these unique IDs for each of these assets is they also double as fingerprints in some cases. So let's say you've got a vendor-provided door controller, and the door controller has a hard-coded TLS certificate in every firmware by default. Well, yeah, it's a security risk that's got a hard-coded TLS cert, but it's not going to be that big of a problem for you in reality. However, we can use that TLS cert now as a fingerprint to tell you, hey, this thing's a door controller. So kind of as a side effect of doing fingerprinting, we're able to do some of these neat attack surface management techniques, but they're also really useful for being able to fingerprint devices that are otherwise really difficult to tell apart. And we use a bunch of really neat techniques. So for example, if it's got a really generic SSH banner, we can probably still fingerprint it well by looking at other bits of the TCP IP stack. So we'll look at like the TCP window scaling, we'll look at the TCP window size, and that'll usually tell us the combination of the Linux kernel plus the OpenSH package name. And if we basically run that through a lookup table, we can tell you, oh, this is RHEL 7. So there's a lot of kind of subtle ways that you can do fingerprinting, and that's kind of our bread and butter here.
Great. All right. Next question. What are some of the most surprising or unexpected insights you've gained from your inside-out approach?
I did not expect Spectrum to be giving me free internet access 6 months later. I found that out this morning while preparing for this.
That's a good one. Yeah. All right, good. Now you talked a little bit about this. People are asking, like, what are some of the real world examples? I guess some of the things that you've helped customers uncover. You mentioned some of the endpoints. Yeah.
Yeah, the gnarly ones are like, you've got we had a customer in the UK where we use the same DCRPC trick to enumerate secondary interfaces. We found that a lot of their executive laptops had mobile cards, and depending on which telecom carrier is roaming to, either you couldn't connect to any of the ports or everything's wide open. So it really depended by day. Like sometimes the device would come up and there's nothing you can. It was basically a V6 connection to the LTE card, and so, sometimes you can connect to port 3389 and 445, and sometimes you couldn't reach it at all based on that particular telco that they happen to be roaming to. So that was really surprising because it wasn't just like, oh, it's exposed. It's like, no, it's sometimes exposed depending on whether they're at the coffee shop or down the street, depending on which tower they're next to. So it's pretty wild, like just how fiddly some of the stuff can be in terms of detecting exposure. But the key thing was that we were able to determine that those devices did have a secondary interface, they were being enabled, and the host firewall was not being enabled.
Okay. Oh, okay. Here's a question. Do you have capabilities for reporting trends, trend reporting?
Absolutely. There's some trend reports in the product. We really try to focus on two kinds of trends for every metric. So not just here's your most common stuff over time, but here's your least common stuff. So if you go to the dashboard and runZero, you'll see a bunch of trend lines there for most common ports, most common hardware, Mac provider, sources, services, software, things like that. If you dig into both the view more and the view less screens, you'll get these really long reports of each individual thing that we saw, and then the trend line for that thing. So you can say, do I have more or less Firefox installations in my environment that I did before, things like that. So there's lots of things you can build trend lines for. So anything that we create a metric for, we track trend lines for at least 90 days out of the box.
That's great. All right. It looks like we've handled all the questions. HC, any closing statements before we say goodbye?
Not so much here. I mean, love if you have a chance to check out runZero, we really like your feedback. You can go to runzero.com/try. Also like to mention we have a free tier. So we have something like 30,000 users who are using it in their home labs, and just to kind of keep an eye on their home stuff. And that's great. We also support a lot of small businesses on the low end for free. So if you have less than 100 assets in your environment, the product is free, and it does pretty much everything that our commercial version does on the tin, including the new features here that we're talking about.
Very cool. All right. Thank you very much. I'd like to thank our sponsor, runZero, and I'd like to thank everyone out there in the audience. We appreciate your attention and participation. Within the next 24 hours, you'll receive a personalized follow-up email. It will contain details and a link to today's presentation on demand. If you have colleagues and peers who didn't join us today, let them know they can check out this webinar on demand. This webinar is copyright 2024 by Informa. Presentation materials are owned by or copyrighted by Dark Reading and runZero. And the individual speakers, we're solely responsible for our content and opinions. On behalf of our sponsor, runZero, I'm Peter Krass. Thanks for your time. Have a great rest of your day.